Hello and welcome to Graphing Trig Functions Part 2. Today we're going to look at how we can change the period of the graph. And the graphs we're talking about are sine and cosine. Actually, I guess we're also talking about tangent, but we'll do that a little bit later on. For these two graphs, the regular period for this graph is 2 pi. All right, and that completes one cycle. Now what we want to do, we want to either compress it horizontally or expand it. We want to stretch it or, kind of move things about, changing it horizontally. What we've seen in the past is to do that, you've got to take the function, you've got to locate x in the function, and then you put whatever number you want in front of the x, and that's what affects the change horizontally. So in this case, we're talking about putting in some number in front of x, whatever that number happens to be, and whatever function we happen to be working with. Okay, so these are the numbers that are crammed inside the function. And remember, it is the reciprocal of these numbers that causes the change. All right, why don't we look at an example with some actual numbers and see if we can make sense of it. So let's see if we can graph y equals sine of 2x. Nice, friendly, happy little 2x. Okay, so the number that's in front is 2, which means it's reciprocal of 1/2. So everything horizontally is compressed by a factor of 1/2. So in other words, what was the original period? Well, we want half of the original period. So we really want to cram this graph into half of 2 pi. So really what's happening now is the graph has a new period of pi. New period. Now the easiest way to graph this, okay, and there's no other changes happening in our graph. Easiest way to graph this is to still mark down 1, 2, 3, 4 key spots on my graph. The only difference is now that it finishes at pi, not 2 pi. Okay, so now what I got to do is just figure out what these distances are. Well, this would be half of pi. And so that means each of these distances are essentially a quarter of pi. So this is like 1/4, 2/4 or a half, 3/4 of pi, and then 4/4, which is pi. And that's when I want to finish the complete cycle. Goes to a maximum of 1 and a minimum of -1. And my key points for sine are 0. Then 1/4 of the way through the cycle, it maximizes. Then the next quarter takes it back to 0, the next quarter down to -1, and then finally when the cycle's done, I'm back at 0. Now I'm going to join these key points together. Oops, let's try that one again. Okay. And there it is. There's the changed period. We can see, the new period is pi. One cycle is done within a space of pi. All right, let's do one more example. This time, let's do a tangent. I told you we were going to do a tangent graph. So let's do, what if you had tangent of, and it was x over 3. Okay, so the number in front of x, you might find it easier to look at it this way. The number in front of x is 1/3, so its reciprocal is 3. So what I want to do is go 3 times what the old period was. Okay, now the old period for tangent was actually just pi. Okay, remember that within pi, you finish the complete cycle of tangent. So this is the new period. Okay, so it takes 3 pi to do one of these tangent graphs. So let's get the grid back up see what we can do. So normally we had 2 key points to draw one of these tangent cycles. Normally this would be pi by 2 and pi. What I got to do now is I got to change that and make it, so this was pi when we finished. Now I got to go to 3 pi. So let's see, that was half a pi, pi. All right, so then we need to get to 2. That's 2 pi's here. And we've got, all right, so a little bit longer than I thought it was going to be. Yeah, we got to get all the way to 3 pi. All right, now halfway through this is where that vertical asymptote is. So this is the end. We know tangent starts at 0 and ends at 0. And halfway through, it's got to be about here, right? So it's like 1.5 pi. So that's where we have to draw in the vertical asymptote. And if I really want to get fancy, I could even say halfway between this, we were at 1, but I don't even think I want to get that fancy. I want to basically show what this graph looks like, and so this goes roaring up to that vertical asymptote, and then from this side here, we got to go over to that vertical asymptote. And so there it is. There's the new period, there's my graph. Oh, happy day. I think I'm going to call it a day, and we'll catch you later.